Oh, thank you very much. And the theme of this meeting is future is now?
Future is now.
Is now. Therefore, I selected. Okay, we do that. No. Is that okay? Anyway, I sincerely appreciate your kind invitation, and also I'm honored to be here in a beautiful country and Thailand. And I have been to Thailand probably more than 15 times, and like a home country. Thank you very much for the invitation. Anyway, and today I'm going to talk about the upcoming technology of TKA in the operation room. For successful TKA, it is indispensable to obtain the accurate bone resection and well-balanced soft tissue. However, it is reported that more than 10% of TKA show outlier, even when performed by experienced surgeons. Some techniques have been developed in both measured resection and gap balancing. However, still, the assessment of the soft tissue balancing is based on the surgeon's subjective feel as an art form. For example, if a senior doctor said this is very well balanced and well balanced soft tissue balancing, but we cannot check it. Just a senior doctor can touch that. Maybe your tightness must be a little looseness of my film. Anyway, to improve the accuracy in TKA, many kinds of computer technology have been developed. The image-free computer navigation system can obtain the accurate coronal and sagittal alignment. However, it's still controversial in axial alignment because we have to match the CT image or some virtual image to the real bone, such as femoral condyles and tibial condyles. Okay, that is a registration. The registration process is very, very difficult because soft tissue covers the surface of the bone. Portable navigation system with accelerometers and gyroscopes are handy and cheap, and can also obtain accurate coronal and sagittal alignments, but they are not available for axial alignment. PSI are available for all bone resection, including rotational alignment, but they are still controversial for stability and alignment compared with the conventional method. Also quite expensive. Robotic surgery are now second generation, in which the bone resection is supported by robot, but we haven't tried it yet. But it will be coming to our country, Japan, maybe this year. Quite expensive anyway. For the adequate soft tissue balancing, electric force sensors have been developed. These could obtain the balanced knee with optimal femoral rotation. However, they are not available in Japan. Malrotation of the femoral component, even excessive internal and external rotation, can lead to the early failure of TKA because of PF complications and knee instability. The center of the knee rotation is generally considered to be the surgical epicondylar axis. Therefore, the femoral component is necessary to be implanted parallel to the SEA when applying the measured resection technique. However, the sulcus of the medial epicondyle is covered with MCL and flattening or bone formation in ONE. So it's difficult to recognize in some cases, even when applying a computer navigation system. To obtain the accurate SEA, we have developed an original superimposable CT template system, and it was recently published. And so today I will introduce this template technique. Because the epicondyles are three-dimensional structure, three serial slices of the images instead of the single image, in which the medial epicondyle and or the lateral epicondyle are visible, are selected after the identification of the distal femoral outline by using a computer software. These three images are merged into a single image, and the SEA is subsequently drawn over it. Thereafter, another two serial images indicating the assumed level of the distal femur resection are extracted. This level is approximately 9 mm proximal from the distal end of the femoral condyle, which indicate the thickness of the standard femoral implant. The resection level slightly vary for each case, and thus two images are prepared to increase the accuracy of this approach. The outline of the femoral distal femur is then deselected, and SEA drawn area is traced onto these images. The image with the SEA are calibrated using a magnification rate, and then printed onto transparent films at the actual original size. And finally, the film before their use. And we sterilized it for the surgery, real surgery. Okay, this is a movie, shows how to apply the template in TKA after the distal femoral resection with the conventional method. The CT template is sent on the surface of the distal femur. Then the SEA on the template is duplicated onto the distal femur. After that, the distal femur is resected parallel to this SEA with an AP cutting jig. The accuracy of the femoral rotational alignment of patients and those with the routinely 3 degrees externally rotate from the posterior condylar were evaluated. We compared it. The results showed that the PCA in the experimental group was more concentrated near the target compared to the PCA in the control group, and the outlier were much fewer. Very simple technique. You can create one transparency film with a transpecondyle axis, also outline of the femoral condyle. Then this one can be sterilized. Then you put this film onto the femoral condyle, and which we cut already. Then we can adjust the virtual image to the real image along the outline of the femoral condyle. Very easy to do. Our CT template is easy and inexpensive to make from a preoperative CT image, and it is only takes a few minutes to use during surgery. The CT template does have the confounding influence of the bone degeneration, because we refer to the total outline of the bone surface. The SEA is drawn on the bone resection level instead of the epicondyle level, which is usually used but doesn't appear during surgery. But next step. This technique is very, very simple, but very, very classic. It's not high tech. But virtual reality, virtual reality, as you know, a set of images and sounds produced by a computer that scene to represent a place or a situation that a person can take part in. Probably virtual reality is apart from the real world. Probably this technique and this technology can be used for maybe preoperative education, something like that. Also, maybe we can be trained, maybe a brain train, softening, something like that. How about this one? Augmented reality. Do you know and Pokemon Go, Pokemon, and also the same thing. The augmented reality is currently and widely used. Image produced by a computer and used together with a view of the real world. AR is based on the real world. Therefore, we see real world with a virtual image. That is augmented reality. Therefore, we are developing AR surgery in which preoperative planning and the computed image are overlaid on the surgical site intraoperatively. Hope to see it in a clinical use very soon. I'm going to show you and image and movies. And this is the like a smart glass, and this one, this glass is see-through glass. This monitor is see-through. You can see this monitor image, also and the real world, which is maybe a surgical area. Also, you can see this röntgenographic image around your eye. Then you can overlay this virtual image to the real bone, and then no need to use the we don't need to sterilize the classic films in the surgical area. Okay, this is upcoming technology in the total knee arthroplasty I introduced. The CT temperature technique was proven to determine the accurate SEA. We are developing now augmented reality technology for total knee arthroplasty. Oh, thank you very much for your kind attention.